Hi all, welcome back to the Testing Mentor. Imagine you're testing a checkout feature in an e-commerce application. Everything works perfectly in your application, but the payment is handled by a third-party payment provider. Now, suddenly payments start failing, API responses are delayed, your tests start failing randomly, and the interviewer asks, how would you test a feature that depends on a third-party API? If your answer is, I'll just call the real API in my automation tests, you're already missing the bigger picture. Today, we are going to break down how senior SDETs approach testing features that rely on external APIs. This question is not about writing API tests. The interviewer is evaluating whether you understand dependency management, system reliability, failure handling, isolation in testing, mocking, and service virtualization. Third party APIs introduce risks that you don't control. For example, API downtime, rate limits, network latency, unexpected schema changes. So, your testing strategy must account for these uncertainties. First step is understanding how the application uses the third party API. Ask questions like, is the API synchronous or asynchronous? Is it used during critical workflows like payments or authentication? Does it return real time responses or queued responses? What happens if the API fails? Understanding the integration point is critical before designing tests. A very common mistake is using the real third party API in all automation tests. This causes several problems. First, rate limits. Many APIs allow only a limited number of requests per minute. Second, test instability. If their service is down, your tests fail even though your system is working. Third is the cost. Some APIs charge per request. So, calling real APIs in every test is not scalable. The recommended approach is to mock the third party API during automated testing. Mocking allows you to simulate API responses without calling the real service. For example, instead of calling a real payment gateway, you simulate responses like successful payment, declined payment, network timeout, invalid card error. This allows you to test different scenarios in a controlled environment. Even if you mock the API, you still need to ensure that your integration matches the real API contract. This is where contract testing becomes important. A contract defines request format, response format, required fields, status codes. Contract tests ensure that your application and the third party API remain compatible. When dealing with third party APIs, failure testing is extremely important. You must validate how your system behaves when the API fails. Examples include API returns 500 error, API response times out, API returns unexpected data, network connectivity issues. A robust system should handle these gracefully. For example, instead of crashing, the system may retry the request, show an error message, fall back to backup service. These scenarios must be tested. Many third party APIs enforce rate limits. For example, 100 requests per minute. Your testing strategy should validate how the application behaves when the limit is exceeded, whether retry logic works correctly, whether exponential backoff is implemented. Ignoring rate limits can lead to production outages. Even though mocking is useful, we still need some tests against the real API. But these should be limited. Typically, smoke tests, integration tests in staging, periodic validation tests. The goal is to verify the real integration without overloading the API. Another challenge is test data. Many third party APIs provide sandbox environments. For example, payment providers often allow test credit cards. Your automation framework should support switching between mock APIs, sandbox APIs, production APIs using configuration management. When third party integrations fail, debugging becomes difficult. So, observability is essential. Best practices include logging API requests and responses, tracking response times, monitoring error rates, alerting on failures. This helps quickly identify whether the issue is in your system or the external service. In an interview, you can structure your answer like this: understand the integration point, avoid calling the real API in every test, use mocking or service virtualization, validate API contracts, test failure scenarios and edge cases, validate rate limits and retry logic, run limited tests against the real API, ensure observability and monitoring. This shows system level thinking. Testing third party integrations is not just about API calls. It's about designing a reliable system that can handle external dependencies. And that's exactly what interviewers want to see from a senior SDET. If you're preparing for product company SDET interviews and want structured preparation, I offer limited one on one mentorship. You can find my email ID in the pinned comment below. And in the next episode, we'll discuss another tricky SDET interview question. Thank you for watching.